Hello again, everybody, and welcome to another Geo-Institute live stream. As you can tell by my background and the little hat on the 30th anniversary logo, and maybe by the hat on my head, and if you looked at your calendar recently, it is December, and that is the time of year, viewers, where we celebrate. My name is Brad Keeler. I'm the director of the Geo-Institute, and thanks for joining us this afternoon for the third and final live stream in the Maccaferri 2025 live series. If you don't know anything about the Geo-Institute, after you watch this live stream today, you could do it during the presentation, but let's wait until it's over. Catch all the goodness, then go do this. Head over to geoinstitute.org. You'll find out all kinds of things about us, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. And if you like what you see today, and we're bringing the festivity, we're bringing the technical information, we might bring other things. You should click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. Now, again, one last thing before we start. It is December. It is a great time. It's always a great time, but the end of the year is an especially great time to, again, head over to geoinstitute.org and make your contribution to GI student programs. Jean-Louis and Janet Briot donated an incredible $500,000 to student programs last year, and if we match that amount, we have endowed our student programs fund. So we encourage you to go to the website, click on the link that says Student Program Fund or Student Participation Fund or something like that. We have amazing thank you gifts, including Ralph Peck bobbleheads for contributions of $96 or more. Eric's got his right there. He's more prepared than I am, and they're more than half gone. So you want to get yours as soon as you can. Now, who is that Eric person I mentioned just a moment ago? He is the individual who's going to host this thing today and moderate it from the University of Colorado. It is Eric Jensen, and he's going to tell you about what you're going to see today and why it's going to be amazing, and then we're going to have a presentation for you. Eric, take it away.
Thank you, Brad. Yes, so my name is Eric Jensen. I'm at the University of Colorado, and I am the chair of the GEI's Outreach and Engagement Council. So if you have any questions about our various outreach and engagement-y efforts, please, contact Brad and his staff, and they'll get you in touch with me. So stuff like younger member stuff and student programming and all things Geo Challenge, that kind of thing. Contact Brad, and he will get you in touch with me. So for today, we have, as Brad said, the third in this series from Maccaferri. We have presenting today is Anna Paris, who is a business development manager with Maccaferri North America. She has over 15 years of experience in national and international projects concerning all sorts of stuff, from flood protection, drainage, erosion, stream restoration, slope stabilization, all from design to construction. She has a master's degree in environmental engineering from the University of Trento in Italy, and was a visiting scientist at CSU, go Buffs, in Fort Collins, Colorado, working on sediment transport and river hydraulics projects. So without further ado, we're going to turn this over to Anna and Maccaferri.
Awesome. Thank you so much, Eric. And thanks everyone for being here today. I'm going to start sharing my presentation. All right, just a quick check if you guys can see it.
We can.
Awesome. All right, thank you so much again for this opportunity, guys. Today, I have the pleasure of presenting to you a software that is called Macro Design. It is a simple tool that can support the design of channels with erosion protection systems for flood hazard mitigation. Just let me briefly introduce to you the company, Maccaferri. Actually, Officina Maccaferri was established in 1879. Yes, more than 140 years ago, in Bologna, Italy. That is where I come from originally. And that was for the production of steel wire products. And today, Maccaferri is an international company that is manufacturing and selling double twisted wire products and geosynthetics. We have presence all over the world. We have about 60 subsidiaries and 25 factories. Specifically in North America, Maccaferri was established in the 60s, and the first headquarters was in Williamsport, in Maryland. So the history of Maccaferri and erosion control started in 1894 with an innovative solution for erosion control that was the gabion basket. At that time, there was a riverbank breach, a damaged riverbank, and basically they came up with this idea of using these baskets, filling them with some rock, and then reconstructing basically the riverbank. If you actually go today to that spot that is in Casalecchio along the Reno River, close to Bologna, you will still see those gabions. It's an old technology. Obviously, the technology has evolved. You might see some rust on the wire because it was pure steel, but it's still there, and it's still holding up and very nicely integrated with the landscape. So today, Maccaferri offers a very broad portfolio of solutions, from rockfall mitigation products all the way to pavement reinforcement with geosynthetics. We have a whole bunch of earth soil retaining systems, from MSE walls to reinforced soil slopes with the green Terramesh, and then the classic gabion gravity wall. Today, we will focus on hydraulic works and a software that can support the channel erosion protection design. In terms of services that Maccaferri offers, just to give you an idea, we don't just sell products and manufacture and sell them, but we support the development of projects from the very early conceptual design all the way to construction. We can support the design during all the stages, from the preliminary design all the way to the detailed design, with the drawings, calculations, technical documents, and also cost estimates. We assist the contractors during the bidding stage and during the construction if they need assistance during the installation. So we pretty much assist in developing the project from the start to the end. So today, our focus is to discuss the software that we have developed and that can help you when you need to find an effective erosion protection system for a channel. The software is called Macra Design. So we're going to go through a quick introduction, seeing a little bit the capabilities of the software. Then we'll go to the data workflow, and then we'll jump into a live demonstration. I'll show you how to use the software, and you feel free to try the software yourself. At the same time, I'll show you the link, and then we'll do a little trial. We'll do a design example and comparison with the reprep, and then we'll see quickly a couple of recent projects that we have done. And at the very end, we'll talk about questions and answers. So now, let me start with a guess. If you're here today, you have probably found yourself wondering, in one of your projects, what could be an effective way to protect a riverbank, a spillway, or even a small beach from erosion. Maybe you have just a little information on the geometry and the hydraulics of a channel, and you're wondering how to estimate the erosive forces. Or maybe you have already built your 2D models and know the distribution of the shear stress, but you're not sure what kind of erosion protection system you could propose to your client. And maybe you want to propose an alternative to riprap. Maybe you would like to compare different scenarios and identify different areas in your cross-section that can support vegetation growth and enhance the ecosystem. Or maybe your calculation, you need a big size reprep. That's the calculation. You got big size reprep, but it's not locally available. And you're looking for some more cost-effective solution. So with all these challenges in mind, we have developed this simple tool for a quick assessment that can support your channel design. So the software Macro Design can support either the design of channel and bank protection or grade control structures. Some of you maybe are familiar with the ancestors of Macro Design. For many years, the engineers have been using Macro 1 or Macro Studio for channel design and Macro 2 for grade control structures. Now, Macro Design is the latest version of this software, and it has many improved features and a wider material database. And also, you will see, has a much more modern, user-friendly interface. The Macro Design is a very simple and fast tool that can help you determine the erosive forces along the channel cross-section and compare the resistance of different materials picked from a database. You can combine natural and engineered erosion protection systems along the cross-section and compare the results with the vegetated and non-vegetated solutions. The software runs a uniform flow analysis and returns water depth and flow velocity. So it allows like a flow capacity optimization, for example, modifying the cross-section geometry. You can model any kind of cross-section size and shape from wide rivers to small drainage ditches. The purpose of Macro Design is to support your design of riverbank protection systems and channel linings to mitigate erosion. The software has a modern and intuitive interface. It just requires few input data and returns the result in a very nicely organized manner. It also creates a summary report that is available for download if you wish. You can pick between 10 languages and also choose if you want to use the metric system or the imperial system. So additionally, and more importantly, Macro Design is an online design software suite. That means you do not need to download it. You can use it just with an internet connection. You just need to create an account and will have access to this tool and your own projects from anywhere. In this way, you will always have access to the latest version of the software instantly, and there is no need to waste time searching for updates or take space from your computer memory. The software is available for use at edesign.maccaferri.com. When you type that in, this is the page you will land. And basically, you will see a bunch of different software. The software you want to click on is called Macro Design, right there at the bottom right. If you're just searching from our webpage, then you can click the top 3 bars, and then this will show you this design software. You can click on that, and then you will go to platform, and then you land on the same page. Here you have Macro Design. So Macro Design gives you both the options of designing channel and bank protection or grade control structures. So today we focus on channel and bank protection. Just remember, this tool is for designing stable channel cross sections running uniform flow analysis. So now let's check a little bit the data workflow. from input data, then we'll see a little bit about the equations, the calculation, the approach, and then the results, how they look like. So starting from input data, the information that the software requires is the geometry of the cross-section, some hydraulic data such as discharge and the slope of your channel in that area, and then you will need to associate to each part of your cross-section a certain material. Starting from geometry, basically the software offers some templates you can click on, and then you can start from that one and modify it. That's the first step. Then you will need to add the flow rate and the channel bed slope. And last but not least, you will need to give to each part of the cross-section associated to a certain material. There's a database inside that is divided in 3 categories: natural soils, natural vegetation, and protection system. So natural soil and natural vegetation, basically, you will see inside, you will see some different types of soil, different type of vegetation, and the information that the software has inside in the database, like in terms of shear stress and Manning's coefficient, comes from literature. On the other side, for protection systems, you will see different engineered systems, such as like you will see the option to select reed prep, or you will see different products for erosion control system or earth retaining systems. Starting from erosion protection system, there's a product that is called Maccaferri One Polymac inside. This is a turf reinforcement mat. So this is the type of product that you would use when you have a mild sloped bank, let's say, that is stable from a geotechnical point of view, but kind of needs help with with the erosion. So this product can be, it's kind of a soft armor vegetative solution. The product itself is made with this steel wire mesh, the double twisted wire mesh, and has the 3-dimensional polymer matrix all around. And basically this supports vegetation growth through it and works together with the vegetation to prevent erosion. This product is typically used in the upper part of the bank, on levees or small drainage ditches that are dry most of the time and carry water basically only during storms. So basically you need an environment where the vegetation can grow through it. We've done extensive testing at the Colorado State University on this product to determine the performance in terms of shear stress. On the top left, you can see a graph that shows the allowable shear stress resistance versus flood duration. So like all turf reinforcement mats, the performance drops as the flood duration increases. So a flood duration is one of your design information and parameter that you need to know. And then you see a pretty wide range between if you have the product vegetated or not vegetated. So the highest shear stress is offered for the short term in a fully vegetated condition. So you have about up to 1,900 Pascal, about 20 PSF, let's say, for the very short term. But then the performance drops, like all the TRMs. The second product you will find inside the database is called the Rhino Mattress Standard Polymac. So this is more of a hard armor solution when you have high shear stress, high flow velocity, and you need to protect your bank. Also in this case, this product is just preventing erosion. It's not adding to the stability of the bank. So it needs to be placed on a stable bank, typically a 2-to-1, 3-to-1 bank. This product is made of double twist wire mesh with a special coating. We will see shortly the coating, but it's a rectangular box that is long, wide, and thin, basically. There are 3 different thicknesses, 6, 9, and 12 inches. and it has inside some partitioning diaphragms. That the purposes of this basket, this mattress, we call it, it's basically a basket but wide and long, is to be filled with rock, and then you add a lid, and basically these units will be all connected one to the other and become a monolithic structure that is flexible, permeable, but very thin but very strong. An improved version of this mattress is called the Rhino Mattress Plus. We tried to improve the product, and we did different testing, and then we came up with a pattern tie system that connects the base to the lid every square yard, basically. And so just adding this tie that connects the base to the lid adds even more provides even more confinement effect to the rock, and that improves the performance in terms of shear stress. This is a summary of the Colorado Taste Test campaign that we did. As you can see on the left, you have 6, 9, and 12 inches mattresses. So the thicker the mattress, the stronger it is in terms of shear stress resistance. But also you can notice that if you use the standard mattress versus the mattress plus with the X tie, also in that sense the performance increase, even if you see the same for the same thickness. And we can go up to about 12.5 PSF for the 12 inches. So now these were erosion protection system on a stable bank. Now, if you need to create a bank, a stream bank, for example, more kind of vertical, there's not enough space for a mild slope bank, then you will need to create an earth retaining system. But very much known in use is the gabion wall. Then there are other systems that can be used to retain the soil. Here you can see some examples of more vertical structures along the stream banks and river banks. The software, in this case, the software doesn't run the stability checks in terms of geotechnical stability for sliding, overturning. That will require a different software, and that's a different analysis that we can also help with another software. The hydraulic analysis will just help defining if the shear stress resistance of that particular wall is enough to resist to the applied forces. All these products that have this double twist wire mesh have a special coating. So the wire itself is made of steel, and then there's a special coating that to guarantee longevity. So in the past years, Maccaferri had really focused on developing a very strong coating, and we came up with this Polymax, that is a polymer that offers a great abrasion resistance, very important in water environment where there's sediment transport that can cause abrasion. It's also very hard, UV resistant, a much better coating than many others from the past that are the most common was PVC, for example. In terms of calculation, macro design, from an hydraulic point of view, an erosion protection measure can be designed using the incipient motion theory. So the theory defines and compares the applied shear stress with the maximum allowable shear stress of a particular material. The applied shear stress is the tractive force of moving water against the channel wetted perimeter all along. Then the maximum allowable shear stress is actually the tractive force just before the sediment movement starts. So it depends on the type of the material, on the type of lining that is along the cross-section of the channel. So erosion starts when the applied shear stress exceeds the maximum allowable shear stress. And this is kind of how the result will look like when you run the calculation. It will show you certain areas with in red and give you a warning if the shear stress is not supported. And then you can go inside the material tab and check each part of your cross-section, what's going on in each part of your cross-section. What is the applied shear stress, the calculated shear stress, and allowed. And if it's red, typically the calculated is higher than the allowed. So you need to work and try to find a better product, a better solution. Okay, so now let's jump in the macro design live demonstration. Let's try it. Feel free, if you want, to go on the website edesign.maccaferri.com and click on macro design. You can sign up if you haven't done it yet. Pretty quick, straightforward process. And then maybe you can follow me as I demonstrate the software. So let me share my web page. So share window. All right, here we go. So when you log in Macra, this is the page you will land. So basically, here you see a list of recent projects. These are projects I worked before. If you're new, you will see nothing here, just new project right here. On the top left, you have open. So in case you want to open a certain file from the cloud, or even if you have downloaded a file, you could potentially download this file. You can open that from there. Then you have languages here, and then you have a button here, help, for help. So there's in the help section, there's a user guide and also the macro design scientific reference manual. That one shows you, explains all the theory behind the software, about the equations and data, etc. Now, let me quickly open a new project. So when I click on new project, the first information you need to add is the project details. So all the information, all this asterisk mean that it's a mandatory information you need to add. So let's say trial December 4th, client is the Geo-Institute, and then company details. So that's more the information on your company, country, USA, city, let's say Pittsburgh. All right. Now, on the right side, you see a map. This map allows you to zoom in and find your project. So let's say our project is in, I don't know, close to Pittsburgh. So I'm going to zoom in, and try to find the location of my project. So let's say the project is right here, and I'm just going to click, and then automatically the software will take the location, the latitude, and the longitude, and keep it for you. Then you click next. Here you're going to choose either channel element protection or grade control structures. For today demonstration, we'll focus on channel element protection. We click next. And then here you have available different templates, different cross sections. You can pick whatever you want. It's close enough to your project cross section. So let's say this one, trapezoidal. And then I'm going to select the unit system imperial. In this case, you can choose metric if you want. Now we go next. And here we go. So now, in this case, you see on the left side, you have all the drop-down menus where you need to add information. So In this case, you can see like you can select discharge. So let's say I select discharge, and then you can add the value of your flow rate. You can also potentially create an automatic discharge based on your cross-section and the freeboard. It will automatically calculate the discharge for that freeboard. But let's leave it like that for now, freeboard, and then longitudinal slope. So this is how steep is your channel in this area. Let's leave 1%. Then soil admissible velocity. So this is more what kind of soil you have on site. If you click here, it gives you different options, from fine sand to cobbles and shingles. If you don't know exactly what you have, the most conservative is fine sand because it's the most erodible. So you will select fine sand. Okay. Then you could potentially choose to design a straight channel or a curved channel. Let's say you're designing the outside bank of a stream that is being eroded. You need to fix it. You will choose curve and then add the radius of the curvature of that bend. For now, let's keep it straight. So now we are done with the hydraulic, and now we're going to go to geometry. So geometry, here you can see in this drawing, you can see each part of your cross-section has a number: 1, 2, 3, 4, 5, 6, 7. So when you select from this drop-down menu sector 1, it means you are working on this. Now you can change the geometry, for example. I can choose, instead of being 1.5 to 1, I can choose 3 to 1. And then boom, it will immediately change it. And then you can go back and zoom the right way. Zoom in with these arrows, plus, minus, or this double arrow will just zoom in the right way. And then you can change the height. You can put the height you want, let's say 7 foot, and it will change it. And so on. For each part of your cross-section, you basically define the geometry of that. The number 4 is always the middle of your channel. In this case, it's always going to be plain, and the width, you will have to add the width, whatever is in your project. So let's say, I don't know, 15 foot. And boom, it will change it. Now we're done with the geometry. Material. So now to each part of your cross-section, you're going to need to give a material, associate a material. So if you go to choose materials, here you see the database of the materials. You see protection system. So from the drop-down menu material, there are 3 options: natural soils. So you have sand, cobbles, different options. Then you can choose, or you can choose natural vegetation, and then you have grass mats, dense bushes, and the roughness coefficient, the manic coefficient, and the allowable shear stress that are in these 2 categories, natural soil and natural vegetation, come from literature. If we click on protection systems, now here we have the different products we discussed. We have Gabions, Rhinomattress Plus, Rhinomattress Standard, Maccaferri. You also have RIPREP and also ACBMs. Now, let's start with checking out the Maccaferri. So when I click on Maccaferri, now it is asking me, is it vegetated or is unvegetated with the biotextile? So that's protected temporarily until the vegetation is growing. Let's say we keep it vegetated. Now, there are more information that are required. One is how long is, what's the duration of your storm, of your flood? So now if you have a small drainage channel, probably are in the order of few hours. But if you have a big river, you're looking more at days, right? So this will change, as you can see, as I move it, the allowable shear stress changes because this is taken from the test, interpolated into equations. And so higher, longer flood, lower allowable shear stress, okay? Now, RF is more of a reduction factor related to the vegetation growth. So basically what this is saying, if you click on I, it will give you a little explanation. Basically, this is saying, how confident are you that the vegetation is going to grow nice and thick? This might depend on the climate, depend on many factors, the time of the year, many factors, right? So if you want to be very conservative, you can use a reduction factor up to 3. If you are pretty confident that the vegetation is going to grow nice and thick, you can go all the way to the minimum reduction factor that is used, that is 1.3. So higher reduction factor, smaller allowable shear stress. Okay. All right, next, let's take a look at the Rhinometra standard. So Rhinometra standard, you can select the 3 thicknesses of the Rhinometra standard and then different sizes of rock. Let's check the Rhinometra Plus because it's similar but has more options. The Rhinometra Plus there are 3 thicknesses. So thicker mattress means higher allowable shear stress. Okay, 6 versus 9, 9 is 11. Then you can choose the rock D50. So the typical D50 for mattresses that are Rhino mattresses that are either 6 or 9 inches would be 4 inches, because the rock would be typically well-graded rock between 3 and 5 inches. So 4 inches. In case you have a little bit of smaller rock, you can select that, but that's the typical D50 for rock. So bigger D50, also higher allowable shear stress. So if I click 3.2, you will see 10. If I click 4, you will see, wait a second, 8, 8.9, and then 9. So that's so bigger D50, higher shear stress, higher allowable shear stress. Thicker mattress, higher allowable shear stress. Coefficient of uniformity, this CU, is basically gives you an idea if the rock is well graded or more homogeneous. I always recommend to use kind of 1.5 because it's very rare that you have very homogeneous rock. So 1.5 will be conservative. And then that's it. You will apply it, and you can, even if you have a simple cross-section with the same material all over the cross-section, you can select use material for all sectors, okay? Last but not least, you also have the gabions. So gabions, if you look here, you don't really have many options to select. It's kind of standard because the resistance in terms of shear stress is going to be the same when the thickness is 18 inches or more. Is determined that we assume that the shear stress resistance is about 14.9. And the D50 for the gabions typically is 6 inches, because for the gabions you use typically 4 to 8 inches rock, and 6 inches would be the D50. So that's for gabions. And then you have reprep. So for reprep, in this case, you will need to select D50 in inches, and then the software automatically, let's say I select 12, the software automatically calculates the thickness, assuming 1.5 the D50. Sometimes for some projects, the thickness can be 2 times the D50. It depends. This is kind of just to give an idea for some calculation that we will see shortly. But the software used the shield formula to calculate the allowable shear stress based on the D50 of the rock. Okay, so now let me show you an example for a project. Let's see. Let me go back to the PowerPoint. This one. So now we took a look at the software. Now let's try the software with a real project. So with this example, we're gonna use the software to calculate to design an erosion protection for the banks of this channel that is, as the trapezoidal cross section is 65 foot wide at the bottom, has the depth of 16 foot. The banks are at 2-to-1 slope. The gradient is 0.8, and the flow rate is 26,000 cubic feet per second. What we're gonna do, we're gonna design a protection on both sides. One is gonna be with a reprep, and one is gonna be done with the Rhino Mattress Plus. And we're gonna try to find out what's the D50 and the thickness that works, okay? We're also, as you notice maybe from this cross-section, I don't know if you can see it clearly, but the bottom of the cross-section is divided in 3 parts. It is divided in 3 parts because realistically, when we protect the banks, we also protect the toe of the bank because we want to prevent undermining. So with the software, we want to simulate that we're gonna protect, in this case, we decided to go with 9 foot. Typically, in general, the rule of thumb is if you can estimate the scour, the toe protection should extend for 1.5 to 2 times the depth of the scour that you predict. So in this case, we just simplify, we assume 9 foot. So on both sides, 9 foot toe protection. Now let's go back to the software. Okay, so just to simplify, I already prepared files. So let's start with the Rhino Mattress Plus, okay? Rhino Mattress Plus, this is the cross section. We have 26,000 cubic feet per second, 0.8 is the longitudinal slope. We have a cross section that is 2-to-1 banks. You see number 3, 2-to-1. Height is 16 foot. Both sides are the same, so 3 and 5 are the same. And then number 4 is the bottom of the channel, and it's 65 foot wide. Now let's go to materials. Now materials, we said we selected the Rhino Mattress Plus. In this case, we selected 9 inches with a D50 4 inches and coefficient of uniformity 1.5. So we are in the order of allowable shear stress of 9 something, okay? And we added this. We have this along the banks and at the toe. How do we do this at the toe? You click on subsector here. And now, when you create the subsector, it will ask you which sector of the channel do you want to divide in multiple components, parts. So in our case, we did it with the number 4. And then on the right side, it asks you the number of subsectors. And we said number 3 parts. Now you have left, center, and right. You put the extension on the left, the extension on the right, and then you select for each of them the type of material. So you click there, and basically you select the material. In the middle of the cross section, we selected cobbles and shingles. That's because typically when you have a pretty wide channel, most of the time, if it's a natural channel, you're not going to line the entire channel. You're going to leave some natural material there, allow some scouring, but making sure you protect the toe of the bank, of the string banks. So now we have this cross section, and when we click on run, top right, The software will run the calculation and tell you right away the water depth, the average velocity, again, using uniform flow analysis. And then it will give you a warning sign if there's an area where the shear stress is exceeding the allowable shear stress for that material. In this case, the only area is the middle of the channel where we have cobbles and shingles. So now we click to, at the bottom of the software, you see different tabs. If I click on materials, that is red, it will show you for each part of the cross section, it will show you the material you selected and the calculated shear stress versus the maximum allowable shear stress. As you can see here, we are in the order of magnitude of 9 something allowed versus 5 something. So we have like a safety factor of about 1.7. That could be good. The safety factor, so that means how bigger should be the allowed shear stress over the calculated. It's up to the designers. It depends on typically the consequences and the risk associated to a failure. So typically, you know, for important rivers, big rivers, you want to have a higher safety factor. If it's a small drainage channel, maybe you can use a smaller safety factor, or it depends, okay? These are just raw numbers calculated and from the database. So let's say in this case, it's about 1.7, and the only area that is subject to erosion would be the middle of the channel, and we knew that. Perfect. Now let's check what happens if we add reprep. Now, if you're doing the calculation right now, what you could do is basically save as a cloud file to keep the same cross section and change the name, and then basically save it with another name, and then at that point you will have the same geometry, and you're just gonna change the material along the bank and at the toe to reprep. Now I'm just gonna quickly open the other file that has the reprep to jump to the solution. So here you can see the results. In this case, for reprep, what we did, we selected reprep, basically 23, a D50 of 23, and that will return an allowable shear stress that is kind of similar to the other one. So we are comparing apples to apples in terms of safety factor. And then, so basically now we have reprep 23 inches, D50, and when we check the materials here, we see that in all this, it tells you the thickness, the D50, and allowed and calculated shear stress for reprep, and the same for the middle. In this case, you probably have noticed that if I go back to the channel design, the water depth is higher, and the reason is because now you're using a bigger reprep, so then the Manning's coefficient is higher. That means the water moves slower, but the water depth is higher. So that's why the shear stress, applied shear stress, is slightly different. Okay, now I want to go back to the PowerPoint to show you the results comparison and give you some, just to share some thoughts on that. So let me share the PowerPoint again. This one. No. Yes. Here, window. This one. Okay. So let's check out a table that summarizes the results here. So here you can see the summary for the Reno mattress plus. What we just saw, you see the band protection, how it returns visually. It's very intuitive. It shows you the water depth, the average velocity, And then for the materials, it shows you the summary for the shear stress. The same, so here we have 9 inches with the thick mattress, Rhino mattress plus with the 4 inches, the D50. And here are the results for the shear stress. Now let's take a look at the reprep. You have 23 inches D50 with a thickness minimal would be 34, 35 inches. And we are in the same kind of allowed shear stress. Now, if we compare them in a table, and now we assume, let's say we are protecting a reach of the stream on both sides for a length of about 330 feet, and then on the bank protection with the toe would be 45 foot long on both sides. If you do the math, you will come up with about 3,300 square yards of area that needs to be protected. Now, let's compare the reprep result to the Rhino mattress plus. In case of the reprep, the rock size, the D50 would have been 23 inches. Now, for the Rhino mattress plus, you have 4 inches D50. The rock size, the rock range depends on the guidelines you follow, but it would be between 6 inches and 34 inches, whereas for the Rhino mattress, 3 inches to 5 inches rock, well graded. For the reprep, you may even need to create multiple layers of like gravel filters below, but this is simplifying the calculation. In terms of thickness, we assume the minimum thickness that you would always need to use for reprep, that is 1.5, the D50. And then in case of the mattress is defined because the mattress is 9 inches thick. And then if we do the math calculating the rock weight and compare them, you will see that for the reprep, we will need about 4,270 tons of rock versus about 1,200 for the mattresses. If you do the math, this is basically about 70% less rock that you would need if you use the mattresses. Now, if we convert this rock weight to numbers of trucks, assuming one truck is 40 tons, you will need about 100 something trucks for the reprep versus only 30 for the rock, for the mattresses, maybe plus a couple of trucks for the material, the mattresses themselves. So it's about more than 70 trucks less. Now, if the job site is close to the quarry or the wherever you source the rock, that might have a certain cost impact. But if it's far, it starts being far, then that could change the overall cost of the installation. So something to keep in mind. Also, if you compare the two installations, typically having a mattress is more accurate because you are going to make sure that your mattress is fully filled, and it's very clear to define that. Whereas when you have reprep, to make sure you have a homogeneous layer, when you have big reprep, might be a little more challenging, even more if it's underwater. In terms of maintenance, reprep, because it's a loose rock, may move around. So after the event, when you go and do some inspection, you may notice that rock have moved around because it's loose. You never know about some scarring or movement. Whereas the rock in the mattress is fully encased, in some circumstances the mesh may get damaged locally. It can easily be repaired, opening up that area, placing the rock back inside and patching it up with a piece of mesh, a new piece of mesh. And in general, vegetation growth, it's much harder for vegetation. Like if you have a mattress, riverbank protection, in a place where the climate allows vegetation growth, then over time, you might see some vegetation starting growing on the mattress. naturally. On the other side, if you have riprap, thick layers of riprap, that's much harder. So overall, using the mattresses, Rhino Mattress Plus in particular, helps reducing the volume of riprap. So in case your design requires gigantic, very big riprap, you might want to consider using mattresses to reduce the cost. And now a couple of projects, and then I'm done, just to show you some examples. This is a nice project down in Louisiana, done with Maccaferri to protect the upper part of the riverbank. That's a very good application for this product, where flow velocity are not that high. Most of the time, the water level is below the mat, so vegetation can grow nicely. So here you can see that during the installation of the mat, then in the middle when the vegetation started growing, and on the right side when the vegetation is fully mature, and you cannot see basically the mattress, it's there, but you only see the vegetation. This is a completely different scenario, very cold climate, north of British Columbia. This is a version, temporary diversion of a channel close to Site C, the energy site, if anyone is familiar with that big project. You can see along the banks, in this case, they use the thick mattresses. In this case, they use gabion mats, 1/2 meter, so 18 inches. That's a version of gabions, basically long gabions, so faster installation along banks. And you can see the size of the riprap at the toe to give you an idea of the hydraulics in this context. And last but not least, a nice project down in Arizona, very dry climate, new residential development around an arroyo and around the wash. This is dry most of the time, but when the rainy season comes, it can carry lots of water, lots of sediment. So it's important to channelize the water to be able to develop the areas next to it. And in this case, they created more of a rectangular cross section with a gabion wall, retaining wall on both sides, and a mattress protection at the bottom to prevent scarring. In this case, as you can see, this is a typical cross-section of a gabion wall. A retaining wall is never one gabion on top of the other, needs a wide base and needs to be designed running stability checks, not just hydraulic checks. And that's it. Thank you so much, guys, for attending. If you have any questions or wish to get a PDH certificate, feel free to scan this QR code. And then back to you guys. If you have any questions, I'm happy to answer.
There we go. Thank you so much for your presentation, Anna. They say a picture's worth 1,000 words. I think a tech demo is worth 1,000 slides. So thank you. I always find those very helpful, and you really get a chance to see how software works. So thank you so much. Yeah, if you have any questions, toss them in the chat, and then I will. Looks like I have a couple of here already. Hold on, let me organize myself here. But I do have one question right off the bat here. I might have missed this during your presentation, but I wanted to double check. Does the software create a report or something that you can download and reference later or send to a client or that kind of thing?
Mm-hmm. Yes, actually. Thank you so much. That's a very important thing I think I didn't mention. So here is, let me see, if you can see here the screen, once you run the calculation, let me recenter here, there you go. When you run the calculation, then you can click on export results, and basically the software will create a PDF, even a JP, and create basically a PDF with that summarize the input data, it has a nice drawing, and then the summary of the results. Yes, so definitely yes, and this can be used, in your set of documents you provide with all the technical other documents for your project. Yes, thank you.
Wonderful, thank you. And I just wanted to clarify, what are the specific differences between Reno mattress and the Plus version?
Okay, yeah, so that's the difference is, let me stop sharing. Stop sharing here. Let me go back to this slide that I think it's easier to explain, and just by showing it. Windows, PowerPoint here. So if I go back to the products, if I can, let's go back. Yes, just gonna go back to the slide that shows the two products. So the standard Reno mattress has the same kind of shape, diaphragm, with this kind of elements that basically is the same mesh that is just bent right here and has it's a double layer of mesh that prevents the rock from moving when the water tries to push it. So they both have that, but then the difference is that the mattress Plus has this tie every square yard that is placed at the connecting the base. It's placed at the base. It's a kind of a freestanding tripod, and then you fill it with the rock, and then when you add the lid, you will connect this with some rings to the lid. So then that provides even a bigger confinement aspect to the rock.
Gotcha. Okay, thank you.
Yeah.
We have a question from the audience here. Do you have examples of products that have been used in a reach that was also having a fish ladder system installed?
That's a good question. Products to not sure if they're asking if the product was used for the fish ladder or if it's just next to it. I know, I'm trying to think. I've seen some pictures from the past, but I'm not sure I've seen recently that. However, I've seen projects where I was doing some surveys and I saw salmon going upstream during the spawning season with September or something. So that channel might have had a little more upstream of fish ladder, but I'm not sure. There was a gabion wall there, but I didn't see the fish ladder, but yeah.
Fair enough. We have another question here. Will the vegetation roots damage the geofabric under the mattress?
And that's a good question. I wouldn't say damage. Yeah, that's something that I haven't mentioned, that typically under the mattresses behind the gabion wall, we always place a geotextile, a filter, a fabric that works as both a filter and a separator. I wouldn't think that it would damage it would probably, yeah, penetrate, but I wouldn't say damage. I don't remember seeing any issue with that, any project coming back with that kind of issue. Actually, usually because of the root system, that's kind of anchoring even further the mattress down. So that improves the stability usually.
Awesome, thank you. And it looks like we have one more question from the audience here. It's a question about the Reno mattress, and it says, how is this the Mac mat or the mattress here tied to the earth? Does this work for all soils, sands, that kind of thing?
Yeah. So actually, if the question is for the Mac mat, the TRM, so the mattresses don't typically need to be anchored to the soil. because they're placed typically on a slope that is, let me go to a picture, on a slope that is 2-to-1 or 3-to-1, so not too steep. Sometimes you want to have, if you have something, if it's pretty high, or there's a risk of sliding because of the type of soil, or if there's a liner underneath, you may want to have an anchor. We call it a gabion anchor at the top. So it's something that goes a little deeper, and the mattresses are connected to that, and that will help with the stability against the sliding. The same with the toe. If you have a mattress at the toe that kind of pushing back your mattress on the bank, that also acts as a stabilizing component. This is for the mattresses. If it's the Maccaferri, this kind of product that is basically just a mat, like a very thin layer, then in this case, yes, you need some anchors. So typically you can use, there are different anchors, depends on the project, but what we call a J-pin, that is like an 18 inches rod that you can just pin down in the soil. Then it depends again on the soil, because if it's very sandy, like the pull-out is like, it depends. You can use that kind of anchor, or kind of more of a platypus anchor. It depends on the soil condition. But even in this case, the mats for riverbank protection, typically the bank would be stable from a geotechnical point of view. So there are minor anchors, like not deep anchors. Yeah.
Gotcha. All right. I don't have any other questions for you. So we can all join in thanking Anna for the presentation, and for Maccaferri for providing this time to all of us. Oh, Brad is telling me that he lost audio here.
I can hear you.
Oh, you can hear me, but we might have lost Brad. But at any rate, I'm going to attempt to turn it back over to GI staff here. We'll see if this works. It doesn't look like it might be. Well, oh, wait, we might have gotten Brad back. Let's see. Oh, perhaps not. Any rate, thank you all.
No, I'm back.
Oh, he's back. There we go. I was going to have to go ad-lib an ending here, so I'm happy to have Brad back.
It would have been amazing.
Would have been something.
You're pretty good at that kind of stuff. Well, thanks for an amazing presentation, Anna. And this being the third and final live stream in the Maccaferri series this year, huge thanks to Maccaferri for doing this series with us, and to all the viewers for coming in and asking questions. I always say that's what really makes it great, when we get the questions from the audience. So a huge thank you to anybody who submitted questions today. We did have a couple of questions in the chat about the PDHs that you saw. You saw that QR code earlier. Just scroll back to it. You can go back anytime to that QR code and use it to ask for your PDHs. And of course, this video does stay on YouTube until the end of time, or until YouTube doesn't exist anymore, or something awful happens. So you can go back and watch it as frequently as you would like. While you're on the YouTube channel, you might have heard we have some other videos up there too, so you can check those out as well. As we draw close to the end of the year, again, we're winding down another very exciting year in the Geo-Institute. We have 4 live streams left before the end of 2025, which is kind of unreal, because normally we don't have that many in December. Next week are our web conferences, and as part of those, we have 2 Lunch and Learn live streams coming up. First one will be on Wednesday, and it will be from Keller. And the presentation is on ground improvement successes and pitfalls. So that's the next time we'll be back with you live. The link is in the chat to check out all of our upcoming live streams. You can always register free on Eventbrite for any of those. Anna, thanks so much for doing this today. Wonderful presentation. Eric, stellar job moderating as always. I think we did okay today.
Thank you so much, guys.
Sorry. Our producer today was Aurora Flieger, and we will see everybody very soon with another Geo-Institute live stream.